Hi, my name is Steve Kerfoot. I'm an associate professor here in the Department of Microbiology and Immunology at the Schulich School of Medicine and Dentistry. My research interests are looking at how immune responses are initiated, which is why I'm very interested in how vaccines work. So there's a number of different ways to make a vaccine, but the goal of them are all the same, and that is to train your immune system to recognize one specific piece of a virus so that if you run across that virus again later out in the wild, your immune system will already know how to deal with it and can fight it off naturally. So, it's one thing for a vaccine to deliver a piece of the dangerous virus that you're supposed to learn to recognize. But the other thing that a vaccine needs to do is convince your immune system that spike protein is actually associated with something dangerous. Your immune system has to get a signal that says, you need to learn this and remember it because it could come back and it means something dangerous. So what's happening in the first day or two after you've been vaccinated is your immune system is starting to get that specific signal. So on the news, we've heard lots about T cells and B cells, and we'll certainly get to those because those are the cells that specifically recognize spike. But you also have lots of other kinds of cells, and many of them are living in your muscle, for instance, where you were injected. And their job is to look for signs, general signs of trouble. And so if your immune cells living at the site where you've been injected start getting these signals that something's up, that there may be a virus in the area, they sort of pull the alarm bells and start saying, we think that there is a problem here. But we can't really see what it is. Viruses are good at hiding. That's why we're going to need the T and the B cells later. But they respond with a very general antiviral response to try and hold things into check. So they'll flood the area with antiviral compounds. And depending on how strong your response is, you may start feeling these sort of throughout your body too. So, when you get a fever response, a fever is a way of preventing viral replication. That's part of a very general, non-specific antivirus response. If you feel very tired or if you're achy, a lot of that is sort of like your immune system declaring a shutdown. Stay in bed, don't go anywhere, rest up. It's you have an infection. So that's what you're feeling in the first 1 or 2 days. So it's not really the specific immunity that's going to protect you down the line, but it's an indication that you have tricked your immune system to believe that there's a real infection that needs to be dealt with. So normally when you're infected by a virus is a fairly simple thing. It's sort of a collection of some virus proteins that goes around some sort of genetic material for the virus. And the way a virus infects you is it injects that genetic material into one of your cells and converts your cell into something like a zombie factory that makes more of the virus. But what we really need to be protected from SARS-CoV-2 is we need our adaptive immune cells, our T cells and our B cells, to learn to identify this specific virus, because viruses are tricky. They hide very well. So we need the tools to be able to go and find those zombie factory cells that are hidden in your body. We need to be able to find that specific virus wherever it's hiding. And that training takes time. So it's really not until 10 days to 2 weeks after immunization that you have enough T cells and B cells and antibodies that are specific to the SARS-CoV-2 spike protein that you're going to have any protection. So what we know from the SARS-CoV-2 vaccines that are approved in Canada are that the Pfizer and the Moderna vaccine, the mRNA vaccines, they're approved as 2-dose vaccines, as is the AstraZeneca vaccine, whereas the Johnson & Johnson vaccine is approved as a single-dose vaccine. The trials, however, are also very clear that we are at least partially protected even after 1 dose of any of the vaccines. However, we know that after you get the second dose, your numbers of your antibodies or your numbers of your T cells and B cells that recognize that spike protein go up even higher. So that we know that one dose helps, but 2 doses really sort of amplify the response even better. And when we're in the middle of a pandemic, when there's lots of virus around, it's really key to get those numbers of antibodies and cells as high as possible so that you are as protected as possible.